Okay, I'm doing this video on linear magnification for concave mirrors now, and of course immediately after that we'll look at convex mirror. To save time, I have drawn the diagrams, and in fact part of the derivation I have already done over here, right, so that we are able to spend more time on the explanation part of it. Right, so magnification in simple words means enlargement, right, and it is the ratio of height of the image to height of the object. Right? We're talking of linear magnification, meaning we are looking at only one dimension. So we're assuming that the object has only height, the width is very, very small or negligible, and therefore magnification means the ratio of the height of the image to the height of the object. And we take ratio of image to object because we want to see, or we want magnification to indicate how big the object, how big the image is with reference to as compared to the object. Therefore hi upon ho. Now in this case also we have a sign convention. If we'll take it positive, that is h will be taking positive if it is above the principal axis. For example, here object AB is above the principal axis, so we'll assign a positive sign to HO. If it is below the principal axis, for example in this case the HI is below the principal axis, so we'll assign a negative sign to that. So this is how the sign convention is assigned. Now HO, that is height of the object, will always be positive because object we are always going to place upright, vertical, above the principal axis. So HO will always be positive. HI can be positive or negative depending upon whether the image is erect or inverted. If it is inverted as seen over here, minus sign. If it is erect, vertical, then we will have a positive sign. So this is how the sign convention will be using when we look at linear magnification. This diagram now you must be very familiar with. Right? We have a concave mirror, object AB, right? The rays of light parallel to the principal axis passing through the focus, ray of light which is incident on the pole reflects in this way such that the two angles are equal, and a ray of light passing through the center of curvature reflects along the same path. So these are the three rays that we generally look at, and A dash B dash is the image. Again, of course, it should shown as dotted line. Because the length is very small, I have shown it as a full line. Now when we were looking at mirror formula, we had this equation AB upon A dash B dash is equal to PB upon PB dash, because we looked at two triangles, triangle ABP and triangle A dash B dash P. We compared these two triangles, we found they were similar, and therefore we got this equation. We'll use this equation now. AB is the height of the object and A dash B dash is the height of the image. PB upon PB dash. Now what is PB? PB, as you can see over here, PB is the distance of the object, and there will be a negative sign assigned to it, minus sign assigned to it, because it is in the direction opposite to the direction of the incident ray. Incident ray is going in this direction, PB is in this direction, so minus sign. Same with PB dash. This is PB dash, PB dash. PB dash is in this direction, direction of incident ray is this, so minus sign. So HO upon HI is equal to minus U upon V. Yes, one thing which I forgot to mention over here is HI will have a minus sign because it is below the principal axis. It's an inverted image, therefore minus sign. Therefore, if I put HI as minus sign and this also has minus, so this is the equation I get, and if I write the next step, I'll get HI upon HO is equal to minus V upon U. So this is how we can find out the ratio of linear magnification. Now in this case we had taken a real image. Image is on the same side as the object. In case of a concave mirror, there is also possibility that we might have a virtual image. And when we have a virtual image, what happens in case of a concave mirror is the image, if I take the case of virtual, then in this case the image is virtual, erect and enlarged. So accordingly this equation will change if I use AB upon A dash B dash is equal to PB upon PB dash. In this case, when we have virtual image, what we'll have is we'll have this mirror like this. The object will be over here and the image is over here. This is A dash B dash and this is AB. So AB will be HO. A dash B will be positive HI because it is above the principal axis. PB, this is P. PB is in the direction opposite to the incident ray, therefore I'll get minus U. PB dash is in the same direction. PB dash is in the same direction as the direction of incident ray, so I'll get plus V, and therefore HI upon O will be minus V upon U. And again I get the same formula as I used over here. So whether it is a real image or a virtual image, I get Hi upon Ho is equal to minus V upon U. Let us look at what happens in case of a convex mirror. Again, we have the same diagram over here. Right? We have this A, B, and we have A dash, B dash. In case of convex mirror, we know that the image is always virtual, erect, and diminished or smaller. Now, again, if I use the same equation, AB upon A dash, B dash is equal to PB upon P, B dash. AB will be H of object, this will be Hi. Both will be positive because both object and the image are above the principal axis. The image is vertical, so Ho upon Hi is both positive. What about PB? PB is, this is P, PB is in the direction opposite to the incident ray. So I'll get minus U. What about PB dash? PB dash in the same direction as incident ray, so plus V. And therefore, if I write inverse of this Hi upon Ho is equal to minus V upon U. And thus we get the same equation. So for all spherical mirrors, Hi upon Ho is equal to minus V upon U. That's the equation we are getting. Okay, a last point before we wind up this video. Hi and Ho. If it is greater than 1, that means the image is enlarged. And if it is less than 1, that means it is diminished. So Hi upon Ho. So this is how we will look at whether the size is, if the image is bigger than the size of the object. So that we'll get from this particular ratio. Now if Hi is positive, that means the image is erect, and if Hi is negative, that means the image is inverted. So these are two things that we must keep in mind and not get confused between these two things. The ratio will give us the size of the image with reference to the size of the object, whereas the individual's positive or negative sign will just tell us whether the image is erect or inverted, that is whether the image is above the principal axis or below the principal axis. Thank you.